scientific term. Magnetic flux density of a uniform magnetic field which produces a force of 1 Newton on a wire 1 meter in length carrying a current of 1 ampere when the wire is placed perpendicular to the field. Yes, magnetic flux which produces a force of 1 Newton. It is the Tesla. Thank you. The instantaneous EMF induced in the coil of an AC dynamo. When the plane of the coil, plane of its coil makes an angle 45 with the field. At this particular instant, the instantaneous EMF will be equal to something very important, which is, yes, the effective value. The effective value of the induced EMF. An EMF of 2 millivolt is induced in a coil when the current flowing through this coil changes at a rate of 1 ampere per second. What does this mean? Yes, self-inductance of a coil, self-inductance of the coil is 2 millihenry. The ratio of the electric power or electric energy produced in the secondary coil to the electric power consumed in the primary coil of a transformer, yes, equals 0.9, is 0.9. What does this mean? Okay, efficiency of the transformer is 90%. Efficiency of the transformer is 90%. Also, we can add something here. Yes, we can say the ratio between the produced energy or power, VSIS, over the input power, VP-IP, is equal to 90%. The direct current, once again, let me remind you with the title of the question, write the scientific term. The direct current that produces the same heating effect per second as that produced by an alternating current is 10 amperes. It's all easy for you. It is the effective value of the AC current. So effective value is equal to 10 amperes. Another type of questions. What happens when the two metallic rings in an AC dynamo are replaced with a split cylinder commutator? Okay, the AC current becomes unidirectional but varying current. It is shown in front of you right now. So once again, the AC current becomes unidirectional but is still changing. What happens when the shunt in an ammeter is replaced with another of lower resistance? Okay, with respect to, it asks with respect to the sensitivity of the meter and the maximum current that the meter can measure. What happens to the sensitivity when the shunt is replaced with another of lower resistance? Okay, sensitivity decreases, and this means the meter can read greater currents. What happens or what will happen to the reading on the hot wire ammeter? Hot wire ammeter is a device for measuring AC currents and DC currents, of course. What will happen to the reading on the hot wire ammeter in the circuit when the key is closed? Yes, when the key is closed, this means we are connecting another capacitor. So when connecting capacitors in parallel, capacity increases and XC equals 1 over 2 pi FC. So when capacity increases, reactance decreases and the current increases. So once again, since the capacity of the capacitors increases when connected in parallel. So the capacitive reactance decreases. Capacitive reactance equals 1 over 2 pi Fc. C increased, XC decreases. Reactance is like any opposition. When it decreases, the current increases. What will happen to the reading on the voltmeter in the shown circuit when the value of S is increased? The question now, what does this voltmeter read? Actually, it reads the potential difference across R, which depends on the current. When we increase the value of S, the current decreases, so the voltage decreases. The reading on the voltmeter decreases. Okay. Another type of questions. Mention an application of each of the following. We want an application of mutual induction. Okay, of course, it is the transformer. Also, Rom-Korf coil. Rom-Korf coil is called induction coil. So, application of mutual induction, it is the transformer. Application of self-induction, yes, fluorescent lamp. Application of dual nature of electrons, it is the electron microscope. Application of eddy currents, yes, induction furnaces. Thank you very much. Application of spontaneous emission. Spontaneous emission, it is traditional sources of light, normal light sources. And what about stimulated emission? Okay, application of stimulated emission, it is laser. Application of photoelectric effect, it is all easy. It's all easy for you. It is the photocell. And what about an application of electromagnetic induction? It is the dynamo. And magnetic torque, actually we've got 5 devices. Moving coil galvanometer, DC ammeter, DC voltmeter, ohmmeter, and motor also. So application of magnetic torque, it is the motor. Application of thermionic emission, yes, this is important one. It is cathode ray tube. Cathode ray tube. Thermal effect of the electric current, yes, it is the hot wire ammeter. Another type of questions, mention one use of each of the following. Okay, we need one use. One use for laser in medicine. Okay, it has many uses. One of them is, yes, lasers can be used as cutting or welding tools in delicate eye surgery. Cutting or welding tools in delicate eye surgery. One use for laser in military purposes. Okay, laser has military applications such as precise guidance of missiles and smart bombs. Precise guidance of missiles and smart bombs. Use of X-rays in industry. X-rays are used to check defects in metallic structures because X-rays have high penetration power. They have high penetrating powers. Another interesting question, the figure shown in front of you shows an excited atom. It is found in the energy level E2. Okay, what about the question? Mention the different possible methods by which the atom may relax to the ground state. Mention the different possible methods by which the atom may relax to the ground state. Then mention 3 of the differences between the types of emission produced when the atom relaxes. Okay, first of all, the excited atom or excited electron in the atom relaxes to the ground state after its lifetime is over, and this produces an emission we call, yes, a spontaneous emission. It happens when lifetime is over. Another possibility, the excited electron is stimulated to relax before its lifetime is over, to relax, to make transition to the ground state. If a stimulating photon, appropriate photon having the right energy, which is the difference between E2 and E1, when this photon passes by the atom and stimulates it. So, in this case, we have a stimulated emission. And what about the differences between stimulated and spontaneous emission? Okay, we'll take it one by one. The photons in a spontaneous emission, photons emitted by spontaneous emission, have wide range of wavelengths, many wavelengths. We call it polychromatic. But photons in stimulated emission are almost of one wavelength. We call this, single wavelength, monochromatic. Okay. Another point of difference, the photons emitted by a spontaneous emission propagate randomly in all directions. They are divergent. But the photons emitted by a stimulated emission are coherent and propagate in one direction as a collimated parallel beam. Another difference, spontaneous emission is not triggered, not caused by external influence. But stimulated, is triggered by an external influence. Another type of questions, in front of you we've got a circuit that contains, a capacitor of, capacitive reactance 120, inductive coil of reactance 120. We've got a fixed resistor R and variable resistance. Since XL is equal to XC, the circuit is in a state of resonance. As long as they are equal to each other, XL is equal to XC. What happens when a resistance of equal value to the fixed resistor is connected in parallel with it? Okay, this has no effect on the resonance state, but the resistance, the value of the resistance is decreased and the current will increase. So the circuit remains a resonance state, but the current flowing in the circuit increases. Okay, another item, what happens when the value of the variable resistance is increased? Once again, we didn't change the value of XL or XC, so resonance remains. Okay, the circuit remains in resonance, but increasing the resistance will decrease the current. Another item concerning the same circuit, what happens when the AC supply is replaced with DC supply? We've got a capacitor. What happens to the capacitor? It will be charged. Then the current drops to 0. Okay? The capacitor is charged. Then the current quickly drops to 0. Another type of questions, mention the physical quantity that is measured in the following unit. It's a little bit strange. Your attention, please. It is, we want the physical quantity measured in, yes, ampere squared, second to the power of 4, kilogram meter squared. Then we want you to write an equivalent unit. Okay, we'll try to analyze this. Ampere squared, second, yes, to the power of 4 over kilogram meter squared. Yes, they can be written in the following. Ampere squared, second power 2 over kilogram meter squared, second negative 2. Your attention, kilogram meter squared, second negative 2 is the unit of work. It is joule. So it is ampere squared, second squared over joule. We can say it is equal to, yes, ampere times second is coulomb. Okay, so coulomb times coulomb over joule. But joule over coulomb is volt. Your attention, joule over coulomb is volt. So it is reduced to coulomb over volt. Coulomb is quantity of electricity. Volt is potential difference. Now it's clear, it's quite clear. It is, yes, thank you very much. The formula determines the capacity of a capacitor. C is equal to Q over V. So, yes, thank you very much. It is the farad, which is equal to coulomb over volt. Another type of question. A student disconnects the voltmeter in the opposite circuit. Okay. And connects in its place a battery and a switch. But when he closes the switch, the coil does not rotate as it should in a AC/DC motor. Okay, what about the questions? What is the reason for this? Why it doesn't work properly? Okay, it's all easy for you. The coil will not be able to rotate in one direction. Why? Because of the presence of the two rings. As a matter of fact, it reverses the direction of its rotation twice a cycle because, yes, the two rings always direct the current to flow in the coil in the same direction. Another item, what is the change that the student should make to cause the motor to work properly? Of course, the two rings should be replaced by a split ring commutator. Function of the commutator, split ring commutator reverses the direction of the current in the coil each half cycle to make it rotate in one direction. Another important question. It is actually very important question. And will you please pay attention to this question and the direction of the current shown on the, yes, on the figure. Use the figure to answer the following questions. What is the type of the transistor shown in the opposite figure? You'll be able to recognize the type from the direction of the current. Actually, it is, yes, NPN transistor. What is the state of that transistor, on or off? Actually, you have to focus on the base. The base is connected to a positive terminal, so it is on. On state. What is the value of VC if the current gain beta E is equal to 45 and the emitter current 150 milliampere? Milliampere should be converted times 10 to the power of negative 3. So beta E is given to be equal to 45. It's all easy to determine alpha E. So beta E is equal to alpha E over 1 minus alpha E. So 45 is equal to alpha E over 1 minus alpha E. In this way, we've managed to obtain the value of alpha E. It is 0.98. Alpha E equals IC over IE. Emitter current is given 150 milli, 150 times 10 to the power of negative 3. So the collector current can be determined. it is equal to 0.147 ampere. Now we can calculate the potential, yes, across the collector. IC, RC, 0.147 times 10. It is 1.47. Minus V battery, it will give V out, VCE. So VC is equal to 6 minus 1.47. It is 4.53 volts. What would happen, still talking about the same question, what would happen to the value of VCE, voltage across collector emitter, we call it V out, if the value of the variable resistance connected to the base, yes, was of higher value? So the value in the base is increased. Current of the base, yes, decreases. Collector current is, yes, largely decreased. Voltage across the collector decreases, so output voltage increases. So it increases output voltage, VCE increases because the voltage on the collector decreases. Still talking about the same question, what is the logic gate based on the mode of work of the previous circuit? Yes, thank you very much. It is NOT gate. Another type of questions. Prove that the units of L over R, L is inductance, or ohmic resistance, are units of time. Okay, from the relation EMF induced by self-induction equals L delta I over delta T. So L is equal to EMF times delta T over I. So we can say unit of inductance is volt times second over ampere. But volt over ampere is resistance, it is ohm. So unit of L is ohm second, and unit of R is just ohm. Okay, so once again, talking about L over R, unit of L, we proved it is ohm second, and of R is ohm. So ohm will be crossed out. So we proved that L over R, yes, has a unit of time, second. Choose. When the EMF induced in the coil of the dynamo equals half the maximum value, then the normal to the plane of the coil makes an angle. Normal to the plane makes an angle. Is it 30, 60, 45, or 90 with the direction of the field? Normal, of course, makes an angle 30. If it is the plane itself, it will make an angle 60. Normal to the plane makes an angle 30 when the instantaneous is equal to half the maximum. The ratio of the time taken by a current to decay through a straight wire to that through a coil is greater than, less than, equal to 1. In a straight wire, it vanishes quickly, so it is less than. The transmitted electric signal in the cathode ray tube controls the potential of filament, grid, anode, cathode. Of course, it controls the potential of the grid. Okay. It's high time now to solve a problem. Use Kirchhoff's laws to calculate the value of the current in each resistance and the equivalent resistance of the circuit. The circuit is shown in front of you. Okay, talking about the current in the circuit. Let the main current, the current passing through the battery, is equal to X plus Y. This current at node A, at junction A, divides into X and Y. Okay. And current X at node B divides into a portion Z, okay, and rest, which is X minus Z, passes through the passes through the 2 ohm resistor. At node D, what happens? Current Y and current Z combine to join, so we've got Z plus Y at the resistance 1 ohm between the 2 points D and C. Okay, by applying Kirchhoff voltage law on loop ABDA, we can say minus X minus Z plus Y is equal to 0. So we managed to obtain the first equation, X plus Z, okay, is equal to Y. We are going clockwise. Loops, okay, the loops we are choosing, yes, we are going clockwise. By applying, yes, Kirchhoff voltage law, a loop A, B, C, E, F, A, B, C, E, F, A, we can say minus X minus 2 between 2 brackets, X minus Z plus 13 is equal to 0. So we can say 2Z minus 3X plus 13 is equal to 0. This is the second equation. We'll apply Kirchhoff voltage law once again, but on loop, yes, BC, DB. Okay, B, C, D, B. And don't never forget, we are going clockwise. So minus 2 between 2 brackets, X minus Z plus Y plus Z is equal to 0. So X is equal to 2Z plus 0.5Y. This is the third equation. Substituting for X in equation 1, Y is equal to 6Z. And substituting for Y in equation 3, X is equal to 5Z. Substituting for X and Y in equation 1, Z is equal to 1, Y is equal to 6, X is equal to 5. So the main current, which is X plus Y, is equal to 11. R equivalent, of course, is equal to V battery, 13, over the total current, which is 11. It is 1.18 ampere. It's all easy to determine it. Another type of questions, what are the conditions necessary for ejecting electrons from the surface of a metal with a particular electromagnetic radiation? Yes, thank you very much. The frequency of the electromagnetic radiation should be greater than the threshold frequency. What is the condition for a stimulated emission to take place? Stimulated emission requires the presence of a metastable state so as to reach a situation of population inversion. In this way, we've come to the end of the General Revision edition. Until we meet again, my best wishes to you all. Thank you.